Welcome to a lesson on angle relationships. I have a joke for you. How do you catch a unique rabbit? Unique up on it. Oh, your parents probably know that one. That's an old one. Okay, hopefully you're loose and ready to start the lesson. I want to talk to you about angle relationships. Now, coming into this, I'm hoping you already know about angles, acute angles, obtuse angles, right angles. These angle relationships will be able to be utilized to help us solve for unknowns toward the end of the lesson. There are three types I want us to look at today. So I want you to look at this angle. You already know that that symbol in the corner indicates that that's a 90-degree angle. So now notice I've taken a ray and split that angle. This relationship between those two angles is called complementary. These are complementary angles. Complementary angles are two angles with a sum of 90 degrees. They're going to add up to be 90 degrees. I have information now to tell you that one angle is x degrees and one angle is 30 degrees. So I want you to look at how we set this up. This helps us to write an equation knowing that complementary angles have a sum of 90 degrees. Anytime you can find two angles whose sum should be 90, you can write this kind of format for an equation, something plus something. Those two angles, even if it's ugly, even if it's an expression representing one of those angles, it's something, one angle plus another angle equals 90 degrees. Now you'll notice it's pretty simple. This one of the values of the angles is x, another value of the angles is 30, and once you've filled in those angle measurements, then it's a simple process of solving this equation. I need x alone. So picture drawing a wall through the equals. We're going to subtract 30 from both sides, and the value of x is 60 degrees. And it will check. If you insert 60 in place of x, 60 plus 30 equals 90 degrees. So the takeaways from this page is first to recognize when you have complementary angles. So pay attention if you've got a 90-degree angle symbol, that little box in any corner in a diagram. And if it's been split, then you'll know that you have a pair of complementary angles. The main idea is that complementary angles are two angles with a sum of 90 degrees. And you could set up to solve for unknowns by saying blank plus blank equals 90. And each of the blanks is to hold one of the angle measures. Next we have supplementary angles. Supplementary angles are two angles that have a sum of 180 degrees. So if you'll notice, we're going to start with a straight line. Now a straight line, if you picture it as open it up, this has opened up to 180 degrees like a straight angle would. If you take a line, and I have a ray built off of this line, so the 180 degrees has been broken apart into two separate angles. You see one of the angles is acute and one of the angles is obtuse. Now remember, supplementary means you have two angles who have a sum of 180 degrees. So once they start giving us more information like a missing value that's x and another angle that's 120 degrees, this is the way you set up any two angles that are 180 degrees, supplementary angles. You're going to say one angle plus the other angle equals 180 degrees. And whatever information they've given us is what I'll put into those two blanks. X plus 120 equals 180 degrees. Notice it doesn't look like a right angle. These should not be confused with complementary at all. These would open up to a line if you combined x and 120 degrees. Then you'd be opened up to a straight line like a straight angle. So there's your 180 degrees. Okay, back to the equation. Now I need to isolate x, so I want to subtract 120 from both sides and get the answer of 60 degrees. If you insert 60 in place of x, 60 plus 120 does equal 180, and that's the main difference. Supplementary angles total 180 degrees, complementary angles total 90 degrees. And a fast way, I think, to remember this, complementary is closer to the front of the alphabet, supplementary is further down toward the end of the alphabet, 90 degrees is closer to 0. So complementary angles total 90 degrees, 180 degrees is further down the number line, so supplementary angles total 180 degrees. That may help you keep them straight. The last angle pair relationships are vertical angles. Vertical angles may be my favorite for some reason. They're also called opposite angles. Opposite angles are congruent. They don't have a sum of a certain total. They're congruent to each other. Congruent means their values are equal to each other. Now I have two intersecting lines. Do you see that we have 4 angles that were just created? So it's down there in the corners where they all connect. I have angles 1, 2, 3, and 4. Can you discover which of those angles are truly opposite to each other? Angles 1 and 2 are opposite to each other, and angles 3 and 4. Now the way we could write this in angle notation, angle 1 is congruent to angle 2. They're opposite to each other. So if angle 1 measures 78 degrees, angle 2 measures 78 degrees. Also, I have a pair of opposite angles, angles 3 and 4. Do you see how they're also opposite each other? So angles 3 and 4 are congruent. They're vertical angles, and vertical angles measure the same. So if angle 3 is 105 degrees, then angle 4 is 105 degrees. So the tip for these, look for intersecting lines. And anytime you see 2 lines that intersect or line segments that intersect, then you're going to have an opportunity for congruent vertical angles. So once you know they're vertical angles, then if you know the measure of one, you know the measure of the other. Okay, that's just a little goof. This is not necessary. Okay, back to the problems. We're going to solve problems with angle relationships. I want you to find the value of x and then find the angle measures. So we have to look at this diagram and see what information has been supplied to us. I don't see anything that would indicate we have 90-degree angles, so no complementary relationships. I don't have intersecting lines, but I do have a ray that's intersecting a line that would split up that straight angle. So what I really have are supplementary angles. Now if you'll remember, supplementary angles total 180 degrees. So supplementary gives us the setup for an equation that looks like this. Now what goes in each of those blanks is what each of those angles measures. So the first angle on the left, it's an obtuse angle and its measure is 5x. The acute angle is 4x. So this should be a true statement. If I were to combine angle 5x and the angle that measures 4x, then I should have 180 degrees. So I can combine like terms now, trying to solve for x. 5x plus 4x is 9x. And I have to get x isolated, so I'm going to divide both sides by 9. The value of x is 20. Now 20 is not the angle measure, 20 is the value of the unknown. So I'm going to take 20 back to the diagram and insert 20 in place of x. So I have 5 times 20 and 4 times 20. And if you evaluate that, you'll get each of the angles measures. So one of the angles, 5x, is measured to be 100 degrees. 4x is measured to be 80 degrees. So you've taken a relationship that you recognize, supplementary angles, and then you've set up an empty equation. Something plus something is 180 degrees. You've supplied each of those angles in the equation, the 5x and the 4x, combined like terms, solved it for x. Now the direction said solve for x. We did that and had 20. But then we found the angle measures when we insert 20 back in place of the x in the actual diagram. So it gave us the actual angle measures of 180 degrees. Now we're going to find x again. I have 30 degrees in one angle and 6x plus 12 in the other angle. Do you see the relationship between those two? Would they be vertical, supplementary, or complementary? And that little box in the corner is the big tip-off, and that's a right angle. So these are complementary angles. If they're complementary angles, that means you have two angles whose sum is 90 degrees. And so that's how I set up the equation. Now in place of each of those blanks, let's put one of the angle measures. So I have 6x plus 12 in one of the blanks and 30 degrees in the other blank. And now you can just pretend it were any equation, combine like terms, and solve for x. Have two constants to combine. 12 plus 30 is 42. And now I seek to remove everything from x. I need to isolate my x. So subtract 42 from both sides. And then divide by 6. The value of x is 8. If you wanted, you could plug 8 back in place of x in that second angle. And if you did, you'd find the exact angle measurement of 60 degrees. And it's true. 30 plus 60 degrees does equal 90 degrees. So complementary angles have a sum of 90 degrees. Alright, let's find the value of x. So this is interesting. Let's see what angle measurements they give us. I see nothing to indicate a right angle. I don't have supplementary angles because the angles would be adjacent. They would be side by side if I were going to have supplementary angles. These are opposite angles, which means we have a case of vertical angles. That's the relationship happening here. And if you remember from our notes, vertical angles are congruent. So the setup for congruent angles looks like this. You don't have a sum that you're trying to achieve. You just know that they're congruent. So one angle equals the other angle. So place the measures of each. 2x plus 20 should equal 100. Now solve for x. Subtract 20 from both sides. And you'll get 2x equals 80. Divide both sides by 2. And the final value, x, equals 40. Now, it wouldn't hurt if you wanted to put 40 back in place of the x, just to guarantee that you're going to get back to 100. You already know both angles should be 100 degrees. In this instance, vertical angles helped us to discover what the value of x was. Vertical angles are congruent. Alright, we're going to try to find the measures of all the angles. Check out this diagram. Now I don't have all of them labeled, but before we finish this problem, we will have found the measures to all of the angles. So start observing what you have. Do you see complementary angles or supplementary angles or vertical angles? Complementary and supplementary angles will be adjacent. That means they will share a common ray. Okay, the thing I like to look for first is vertical angles, and I see several. I've added C and W also for us to find. I've noticed that Y and 70 are vertical angles, and W and 20 are vertical angles. So that helps me find the exact measure that 20 and 70 degrees is the measure of Y, and 20 degrees is the measure of W. So just by knowing vertical angles, I was able to find the measure of W and Y. Now I've added a statement that 20, the angle 20 degrees, 70 degrees, and angle X, they all open to a straight angle. Do you see that? That those three angles together would equal 180 degrees. So that information is going to help me find X. 20 plus 70 plus X is going to equal 180 degrees. Combine like terms, subtract 90 from both sides, and we'll see that X equals 90. So now I know the measure for X. X is 90 degrees. Now do you see that X and C are vertical from each other? Since they are vertical, they are also going to be congruent. And now I know all the measures of that diagram, all the angle measures. What started was that I had a couple of pair of vertical angles, so I was able to find the measure of W and the measure of Y because we had vertical angles. Once I knew the value of those, I was able to find the value of X because Y, W, and X would open up to 180 degrees. So we were able to find X, and we ended with the fact that X and C are vertical angles. So if X is 90 degrees, C is 90 degrees. So guys, utilize the fact that supplementary angles, complementary angles, and vertical angles, if you know the relationships, will go a long way to helping you find unknowns in geometry. So go back and watch it as many times as you need. If you need help, also, you can come in to visit in tutoring or to see us. Bye-bye.